Okay, so now we just start our chapter 6 is based on hydraulic machinery. Okay, so we have learned the hydraulic structure. Okay, hydraulic structure is based on spillway, USPR, and so on. Okay, now we look at the hydraulic machinery. Okay, so hydraulic machinery is based on the calculations for pumps and turbine. Okay, you can determine the discharge and energy head of pumps, okay, in parallel and series, and also carry out similitude analysis between model and prototype of pump and turbine. Okay, so you have learned the energy head, okay, of the from the hydraulic structure and so on. Okay, so now we just look at the pump and turbine and also the prototype, okay, model and the prototype of pump and turbine. Okay, so this is also the direct, okay, direct calculation using the formula or the equations. Okay, now we look just the turbine here. Okay, this is for theory. Okay, in your finals, this the theory based on what is the turbine and what is the pump. Okay, so maybe there's mentioned there, define the turbine and pumps and sketch. Okay, and define and sketch the diagram of turbines or the pumps. Okay, so you can define and also sketch the turbine here. Okay, turbine is a hydraulic machine that utilizes the energy of fluids to move other types of machineries. Okay, so common use of turbine is in the hydroelectric power generation plant. Okay, so actually this is the hydraulic machine. Okay, to move to utilize the energy of fluid. Okay, so this is the based on the turbine here. Okay, you have also learned the what is called the HF and the HF. Okay, so you have learned the HF and the HM in your fluid mechanics. So now we look at the turbine and the pump. Okay, so based on the hydraulic action at the inlet, turbines can be classified as impulse turbine, okay, pattern wheel or turbine. Okay, derive its energy from a jet of water exiting out of nozzle and shooting at the blades of turbine. Okay, so this is based on the Pelton. Okay, impulse turbine. Okay, based on the Pelton here. Okay, and reaction turbine is Francis turbine or Kaplan turbine. So they have the two, okay, the two types of turbine. Okay, Pelton, Francis turbine or Kaplan turbine is a reaction turbine. Okay, Pelton wheel is the impulse turbine. So there's two types. Okay, so maybe in your questions ask you to mention or list out or state out the types of turbine. So maybe you can just list out that the turbine is impulse turbine is Pelton wheel. Okay, reaction turbine is Francis turbine or Kaplan turbine. So this derive its power from the equal and opposite reactive power of fluid passing between its blades. Okay, this is based on the blade of Pelton. Okay, so you can look at the Francis turbine or Pelton here in your lab. Okay, in hydraulic lab. Okay, if you take your subject laboratory, okay, hydraulic laboratory, so you can look at the Francis and Pelton turbine in lab. Okay, so you can see that the function of the turbine and also the pump. Okay, so this is based on the direction of flow through the runner based on the Pelton here. Okay, turbine can be classified as tangential flow turbine. Okay, so dia ada 4 type juga. Dia ada 2 type of turbine, Pelton and Francis turbine. So based on the direction, this is based on direction. Okay, so this is based on direction flow, the direction of flow. So the turbine can be classified as tangential flow turbine is Pelton wheel. Okay, radial flow turbine is Francis turbine. Okay, Thomson and Girard turbines. Okay, axial flow turbine is Kaplan. Okay, so the radial flow and also axial flow is Francis turbine and Kaplan. And mixed flow turbine is modern Francis turbine. Okay, so this combination of the mixed flow. Okay, mixed flow of radial flow and axial flow. Then we just use the modern Francis turbine. Okay, so the Francis turbine here based on the radial flow. Okay, so this is the radial flow, and the Pelton wheel is based on tangential flow turbine. Okay, and also Kaplan turbine here, and also the radial flow and mixed flow turbine. Okay, so in case in your final ask you to what is the tangential flow turbine. So the tangential flow turbine is the Pelton wheel. Okay, so you just study and read this theory. Okay, so based on the head of water H, so the water H here, okay, you also calculate the H here. The next slide. Okay, turbine can be classified as high head turbine when the Pelton wheel H is more than 250 meter. Okay, medium head turbine, modern Francis turbine when H is between this range. Okay, and low head turbine when the Kaplan turbine is less than 60 meter here. Okay, so this is based on the head of water. Okay, the previous is based on this direction of flow. Okay, this is based on direction flow. This is based on head of water H. Okay, so Pelton wheel is suitable for medium head and low discharge. So this maybe they have the question that differentiate between Pelton wheel and also Francis turbine. So you can explain about the Pelton wheel and Francis turbine based on the base of head of water based on the direction of flow. Okay, so kalau ada soalan macam itulah, ada soalan yang mengatakan senaraikan perbezaan antara Pelton wheel and also Francis turbine or Francis turbine with Kaplan. Okay, so you can state that the differentiate between that Francis turbines and also a Kaplan. Okay, you just study. Maksudnya teori untuk theory for chapter 6 is more on pump and turbine. Okay, you just study this theory. Okay, so based on this is based on specific speed. Okay, so based on the specific speed, turbines can be classified as low speed turbine when Pelton wheel and S of between 10 to 35. Okay, medium specific speed turbine when the NS between 60 to 400. Okay, this is medium. Okay, high speed more than 300. Okay, 300 to 1000 based on the speed. Okay, the speed is NS here. Okay, so this is based on the, you boleh nyatakan lah kalau ada difference based on the Pelton and Francis and Kaplan. So you just mention that about based on the specific speed. So Pelton have low specific speed. Okay, Francis have the medium specific speed, and also the Kaplan is high. Okay, so you can mention and explain. Okay, you can explain based on this type. Okay, based on specific speed, based on the head of water, and also direction of flow. So the three types. So you can explain based on three difference of this turbine. Okay, so this is based on the theory. Okay, kebanyakan lah dia akan keluar based macam tu lah selalunya. Okay, so you just read this theory. Okay, so now we look at the pump here. Okay, so the pump is also hydraulic machine. Okay, pump is a hydraulic machine which supplies energy to fluid in certain operation, especially in water distribution system. Okay, untuk menghantar air ke rumah pengguna semua, so kita kena gunakan pump lah. Okay, so we use the pump, okay, to supply energy, okay, to fluid in certain operation. Okay, based on the mode of action of conversion of mechanical energy into hydraulic energy, pumps are classified as hard rotor dynamic pumps and also positive. So jadi pump ada dua. Okay, so the turbine ada tiga jenis lah based on that time, based on speed, based on the direction of flow, and based on the other. So for pumps, so the based on the mode of these two. Okay, mode of the mechanical energy to hydraulic energy, the rotor dynamic pumps, and also positive displacement pump. Dua so there's two mode based on pump. Okay, so rotor dynamic pump consists of a rotating device. Dia berpusing. The rotating device is known as impeller. Okay. So fluid to be pumped enters a casing near the shaft of the impeller here. This is the impeller. Okay. So kalau nak nampak lagi lanjut, so if you want to know more about this rotor dynamic pump, so you can see at the hydraulic lab. Okay. So kat situ adalah, so the pump, rotor dynamic pumps based on the impeller here. Okay. Vanes attached to the spinning impeller increase the velocity of the pump fluid and move the fluid out through an outlet. Okay, they based on this impeller here. Okay, the suction here. Okay, and this discharge here. Okay, the water discharge in this flow here. Okay, water discharge for this from this pump. Okay, so the most common rotor dynamic pump are centrifugal pump. Okay, so the jenis rotor dynamic pump is centrifugal pump and also propeller pump. Okay, so ingat kat situ lah. So you must mention that the list of rotor dynamic pump is centrifugal pump and also propeller pump. Okay, centrifugal pump produce radial flow. Okay, based on the radial flow and mixed flow according to the fluid pipe. Okay, propeller pumps also consist of impeller produce axial flow. So this is axial. Propeller produce axial flow. The centrifugal pump produce radial flow and also mixed flow. Okay, so this is based on the propeller here. Okay, based on axial flow. Okay, so power and efficiency of pump. Okay, so in pump operation, the mechanical energy through the shaft and impeller is converted to fluid energy. Okay, so based on this pump here, okay, based on the suction here, okay, flow here, this is pump and it goes delivery to here. Okay, so the difference between the total head of energy between the intake and discharge flange of the pump is denoted as net head, so H. Okay, so H, you also use the H here. Okay, developed by the pump. So the intake and flow inlet of a pump is commonly known as the suction end and the discharge flow. Okay, you have learned the Bernoulli equation or energy equation. Okay, using this part here and also the HF. Okay, head loss. Okay, based on your fluid mechanic. Okay, based on your subject, the previous subject that you have taken, fluid mechanic. Okay, now you apply that the pump in fluid mechanic, okay, and you study here in hydraulic. So the hydraulic is using the hydraulic machinery. So this is called the hydraulic machinery. So you use the equation that you have learned in fluid mechanic also. Okay, so you know that the using the, this is the energy. Okay, the energy equation based from the PD here, delivery, and also the PS here. Okay, so you get the formula here. Okay, so discharge through a pump is given as Q and so on here. So no need to worry. So this formula is given. Okay, so all this formula for pump is given here. Okay, this power. Okay, the power of pump at suction and so on here. So the formula, this formula is also used in your lab. Okay, so dekat makmal nanti you will also use this formula to get the value. Okay, the value of pump, power of pump, power delivered, okay, and the velocity and so on. Okay, so semua tu diberilah. So this formula is given and you want to find the efficiency of pump is given as this formula. Okay, so N is equal to P naught here, okay, divided by Pi. O is actually is outlet. Okay, so P outlet here, power delivered to the fluid, power into the shaft. Actually this power inlet. Okay, power that in inlet here. Okay, and power out here delivered. Okay, so the P naught is Pi, the outlet, and I here, power delivered to the fluid and divided by power into the shaft. So we get the efficiency of pump. Okay, also N is equal to total here and M and H. So volumetry efficiency, M here is mechanical and H is hydraulic efficiency. Actually we use this formula. Okay, so we use this formula. Okay, selalunya kita gunakan yang ni lah, P naught divided by Pi. Okay, P out is divided by Pi. Power of out, power in. Okay, maksudnya power yang keluar dengan power yang masuk. So that's we get the efficiency of pump. Okay, look at the example here. Okay, so a centrifugal pump is needed to supply 23 meter cubic per second of water for a city. Okay, this operation will utilize a net head H is equal to 20 meter and specific speed N. Okay, 450 RPM rotation per minute. Okay, RPM is rotation per minute. Okay, so N speed is rotation per minute. If the inflow power PS is 5,000 kilowatt, okay, the power, and the density of water this using this. Okay, and calculate the output power PD. Okay, output power PD or delivery. Maksudnya PD delivery or P not here. Okay, P not here delivery. Power delivered to the fluid. Okay, PD and overall efficiency of the pump using the here efficiency here. Okay, soalan ni you untuk dapatkan 6 marks. Okay, 5 to 6 marks for this question. Okay, actually this also the previous final exam question. Okay, soalan lama-lama so this is the step by step that you must find the calculation. Okay, solution. So you just use the formula. Okay, to get the output power. Okay, actually for the power is the specific weight times by the Q times by the H. Okay, H is the head. Okay, head here, and Q here the discharge, and the specific weight here. Okay, so you get the specific weight. Okay, 9.8 times by the 1000 here to get the density here. Okay, actually this get the density rho GH. Okay, actually, so you get the 9810 times by 23 times by 20. So you get the power. Okay, so the power output. Okay, output power. Okay, so actually this formula is given. Okay, so this power, the formula is given in your list of formula in your final. Okay, and then you just direct use that P not and PI here. Okay, PI is the power inlet here. Okay, and the power you get here, you just divide by 5,000, so you get the 0.9025, and then in percent, so you get the 90.25%. So you get this one. Okay, so you get 6 mark for this calculation. Okay, maksudnya you guna maksudnya this calculation just only use the formula and you just calculate based on the formula. Okay, that's why that I mentioned there chapter 5 and chapter 6 you can score. Okay, you just study the theory and the calculation based on the formula. Okay, so you can score the chapter. Okay, so they have 6. Okay, they have 6 questions. Okay, and you must compulsory to answer 4 only in your final. Okay, so after this, okay, after this chapter, so maybe the next weeks, okay, and so we will discuss more from revise from chapter 1 until chapter 6. Okay, so this is characteristic curve of pump. Okay, so the characteristic curve of pump is usually provided by the pump manufacturer through laboratory test. Okay, maksudnya pump yang ada kat lab tu kebanyakan kilang akan keluarkan lah they provide, okay, they provide the characteristic of this curve of the efficiency of pump. Okay, so adalah, so this, okay, the head and the pump efficiency is based on the pump. Okay, maksudnya label kat pump tu selalu adalah kat lab semua ada, dia ada they have the manual. Okay, the manual of that pumps, and also they also have this, okay, this table. Okay, that characteristic curve of pump. Okay, so actually the based on the relationship between power input and also efficiency, and head start when intake valve is closed, and the impeller spin in until pressure at output increase to the maximum head. Okay, so this is based on the theory. Okay, kalau dia ada mention that please explain about the P, efficiency, and head. Okay, so you can explain based on your own opinion, okay, by your own word. Okay, you can explain based on this concept, characteristic curve of pump. Okay, maybe the question give you this graph here, okay, the efficiency, the head, and the BEP and so on here. Okay, explain based on this figure. So you just explain based on this. Okay, explain kat sini. You just baca je lah. Okay, you just explain based on what is the power input, what is the efficiency, and the head. Okay, maybe the question asks you to define. Okay, define the PI. Okay, define the input power. Okay, what is the efficiency and what is the head. So you just define based on this theory and from the previous slide. Okay, so this is also the efficiency of performance. Okay, performance of centrifugal pump. Okay, so adalah cara dia macam mana nak cari. Okay, tak apa. So we just look at the example. Okay, after this okay, this is cavitation. Okay, cavitation is an important factor in the satisfactory operation of a pump. Is the avoidance of cavitation, both for good efficiency and for prevention of impeller damage. Okay, maksudnya dia nak pastikan dia berfungsi dengan baik lah. So the good efficiency and for prevent the impeller daripada berlaku kerosakan. So impeller damage. So as liquid pass through the impeller of a pump, there is a change in pressure. So if the absolute pressure, okay, you have learned the absolute pressure in fluid mechanics, okay, of the liquid drops of the vapor pressure, so cavitation will occur. Okay, so the region of the vaporization hinders the flow and place a limit on the capacity of the pump. Okay, so banyaklah. So you just study. So when I mention here, this is as the tip. So you just study for this, for your theory. Okay, kalau saya ada cakap suruh you study. So study sambil saya bagi tahu ni, dia ada tips sekali dah for your tip for your final. Okay, so study for this explanation of cavitation. So cavitation is also most likely to occur near the point of discharge, okay, of radial flow and mixed flow impellers where velocities are highest. So it may also occur on the suction side of the impeller where the pressures are the lowest. Okay, so maybe your question asks you to explain briefly. Okay, briefly explain the cavitation in pump. So you can explain this concept. Okay, the concept of cavitation. Okay, now we look at the pumps in parallel. Okay, so pump in parallel, if two similar pumps A and B are connected, so A and B are connected in parallel, so the combined discharge is the sum of individual discharge QA and QB. Okay, so however, the pressure head H remains the same as in a single pump. So the overall system power requirement is the sum of the power required for each pump at the same head. Okay, so you have learned also the pipe in series. Okay, pipe in series, pipe in parallel, that in fluid mechanics. So now in hydraulic, so you have learned more in pumps in parallel. So the same concept. Maksudnya konsep dia sama. So the same concept that you have learned the pipe in series and pipe in parallel. So you must know that the concept. So total Q, okay, total discharge and the total head loss. Okay, so based on the pump in parallel, so the basic concept here is you must know. Okay, the Q total for pump in parallel is equal to QA plus QB. So you get the Q total. Okay, for head loss here, so head loss total, H is head loss total, is equal to HA and also HB. So you get this one. Okay, and PT is power total. Okay, power in pump here is equal to power at pump A plus power at pump B. Okay, as the basic assumption here. Okay, so you just remember this concept for pump in parallel. Okay, so pump in parallel, so you get this formula, okay, the same here, okay, and the efficiency of total here, so QA plus QB times by HT divided by K times by PA plus PB. Okay, actually K is unit constant, so unit constant is based on the, so K is given, okay, so don't worry, the K unit constant is given based on the value of this one or value of this one, okay, the value of this one based on liter per minute, okay, for meter cubic per second, so we just use this here, okay, so K actually is using, will give, okay, will given, okay, you just mention here, so formula ni adalah, but this formula is not given, this formula is not given, you must remember, okay, you must remember that concept based on the parallel, okay, but for this efficiency, so the give, this formula is given, okay, so but this basic assumption is not given, okay, you must remember this concept, okay, for example here, so determine the system discharge power requirement and efficiency if the pump A and the pump B have the properties here, okay, they have the power here and efficiency here, okay, pump A and pump B, so the operate, okay, operate in parallel, okay, so bila operate in parallel, so you must know that Q total, okay, okay, must QA plus QB, okay, so must QA plus QB, okay, H total, so HA must equal to HB. Ni konsep dia, you kena ingat so this concept, okay, for power, okay, power total, so power total is power A, pump A plus pump B, power at pump A and pump B. So this is the basic assumption that you must know about the parallel, okay. So now you calculate here, okay, so we know that the using the Q total here based on this formula, you just put the value here and then you get this value, okay, for H total, so you know that the HA and HB 27 here, okay, actually the given H here, so just the same value, okay, the H total, okay, so the P total here, power at the pump A plus power at pump B, so you just put the pump here, PA and the PB, so you get this value, okay, then you use that the efficiency of this pumps, parallel pump, okay, so you just put all the value, so you get the value, okay, so now we just use the formula, okay, maksudnya you guna senang-senang je, you guna that formula, so you get the solution, okay, maksudnya senang for this questions you get the at 8 to 10 mark, okay, so you get 8 to 10 mark, 2 mark, okay, 2 mark, 2 mark and maybe 3 mark, so you get the 10 to, okay, 8 to 10 mark, okay, maksudnya senang you just study that this example, okay, must know that the parallel pump and also the series. So now we look at the pump in series, okay, pump in series is based on the series here A and B here, okay, and the basic assumption is this, okay, so the basic assumption for the power total is the same, okay, same as this here, as same as the parallel, okay, but difference based on the Q total and also H total, okay, so you get the assumption here, okay, for this efficiency is the same, okay, so for the efficiency is the same here, QA plus QB, okay, so sama maksudnya efficiency dia sama, so the efficiency of the pump is the same formula, okay, but for the pump in series, so the difference here, okay, difference based on the Q total and the H total, for P total is the same, okay, so now with the same, okay, with the example here, okay, based on the pump link in series, okay, the properties of pump A and pump B is based on this one, okay, actually it's the same, is it the same? Okay, no, okay, lainnya soalan lain berbeza, cuma dia soalan connect in series and connect in parallel, okay, so this is connect with the series, Okay, find the discharge. To get the discharge, pressure, head, total power. Okay, so you want to get the Q, T, P, T, and also HT. Okay, so you get. Okay, so no here, so you just use maksudnya guna terus baiknya the basic assumption, so you get the value. Okay, you know that this formula, so you get this value. Okay, and also this formula, so you get this value. And tu maksudnya ada 4 so you have 4 formula for calculate to solve this example. Okay, because you want to find the Q total discharge, you get the head total, you get the power total, and the efficiency. Okay, so you get 8 to 10 mark for this calculation. Okay, senang je so for this 6, kita berhenti sekejap, so tengah azan, so kita stop sekejap. Okay.